In this video, we'll be exploring graphs of even functions that are based on linear graphs. What is an even function? First, think of an even number of objects and how they are arranged. No matter how you arrange them, they can be split into two equal groups. You don't often think of even-numbered items as having symmetry, but here's an example. This group of 12 items can be split into two groups of 6 that have a line of symmetry like this. Remember this symmetry as we look at even functions. An even function has this property. Suppose that f of x is an even function. This means that f of x equals f of negative x. Graphically, this means that these points on a graph are mirror images of each other. Let's explore this on Desmos. Launch a new Desmos window. You may want to log in. Input the coordinates 1, 2. 1, 2. Then click on Label. And here's the point 1, 2 labeled. Now graph negative 1, 2. Negative 1, 2, and click on Label. These 2 points are mirror images of each other across the y-axis. Next, graph the linear functions that cross these points that also start at the origin. Input this function. F of x equals 2x. F of x equals 2x. And limit the domain to values of x greater than or equal to 0. Brackets x greater than or equal to 0. Next, graph g of x equals negative 2x. G of x equals negative 2x. And limit the domain to values of x less than 0. Brackets x less than 0. You can see that f of x and g of x are mirror images of each other across the y-axis. In fact, the two functions, f of x and g of x, can be combined into one function called the absolute value function. Input this function. H of x equals 2 times the absolute value of x. H of x equals 2 times the absolute value of x. You can see how it overlaps the two separate linear functions. The absolute value function has no restrictions on its domain. And this function has the property that for any value of x, there is a mirror coordinate across the y-axis. Let's get rid of the earlier graphs and stay with the absolute value function. Let's generalize this function by replacing 2 with a variable, a. You'll be asked if you want to create a slider for a. You do, so click the blue button. Click and drag on the slider to see how it changes the graph. Regardless of the value of a, you get the graph of an absolute value function that is even. Each half of the absolute value function is mirrored by the other half. We can even generalize this further. Add another variable, b, next to the absolute value term, like this, plus b, and create a slider for b. Click and drag on the slider and see the effect on the graph. The vertical placement of the graph changes, but it remains an even function. In fact, if you animate the sliders, you can create an endless number of absolute value functions that are even functions.